Hello everyone, hope you're doing good and welcome back to my channel. Today we are at Daily Leetcode Challenge day 14 of the April month 2024, and we again have an easy question in front of us. This question is fully based on the topic of trees, and if you are knowing, at least knowing the how to traverse trees, then I guess this question is the best thing for you to start with. Okay, we'll see that now. But if you are aware of what is a DFS traversal, what is a BFS traversal, or if you're not aware of these things, but at least you know how to traverse a tree, okay, then definitely you can try this question out. This will be a good checkpoint for your own knowledge. Okay, so that's what I wanted to give you as a brief. But let's see this question now. Remember one thing, guys. So see, when I solve this kind of questions, my idea is that you would have at least tried this once. Okay, because see, unless you try, you will not know where you are lagging. Okay, so anyway, but we'll see this question now. But what I expect you is that pause the video, give it a try, and then come back and see how we are solving it. Okay, so I've already given the hints that this question involves traversals of the tree. So get a idea of this and then try to solve it. If you're not able to, then come back to this video and do it. Okay, and if you realize that you have a better approach, then definitely it's worth sharing in the comments so that everyone can know, and definitely we can connect as well. Okay, so if we get to know that you have better ideas, we can definitely do a connect. So let's see this question first. It's sum of left leaves. There is lot of hidden things here in the title itself, but we'll try to decode that after seeing the description. Okay, so you can see this, we are given a root of a tree. What is the tree node? All this will come to that, but let's see the theory of the question first. Given a root of a binary tree, return the sum of all left leaves. Okay, there are three important terms here. First is it's a binary tree. Next is they are talking about two words. Okay, left and leaves. We'll come to this. A left is a node with no children. Okay, sorry, a leaf is a node with no children. A left leaf is a leaf that is left child of another node. We'll come to this. Now see here. First of all, what is a binary tree? Binary tree means any node can have at most two children. Okay, because there are only two children, at most two children. So what we can do is we can call one of them as left and we can call one of them as right. Okay, I hope you are getting it right. One is left, one is right. Only two. Okay, at most two. As simple as that. Now, what is this concept of leaf? What is a leaf now? Leaf basically means that, see, because see, if you see in this particular image, I hope my screen is big enough for you to see it clearly. If you see this image, okay, we are starting from 3 and we are, let us imagine like we are starting from 3 and we are moving downwards. Okay, so we call 3 as the root. Okay, in that way you will get to know that 9, 15, and 7 are the leaf nodes. If you try to imagine what is a tree, it has two ends, right? One is the root, other is a leaf, right? Similarly, in this image, 3 is the root. Similarly, the opposite of that will be the leaves, right? In this case, 9, 15, and 7 are leaves. Now, what is the concept of a left leaf? So try to understand this fact. See, a leaf can be a right child or a left child of its parent, right? In case if it is a left child only, then it will be called as a left leaf. Okay, so in this case, as you can see, 9 is basically a left leaf for its parent, which is 3. Similarly, 15 is a left leaf for its parent, 20. But 7, it becomes a right leaf for its parent, 20. So in this particular image, there are only two left leaves, which are 9 and 15, and we'll have to get the sum of them. 9 plus 15 is 24, so we'll have to return 24 as the answer. Okay, that is what it is. They have given only single example. Okay, the example 2 doesn't make much sense. Now, one second here. See, now, can you quickly tell me, if only a root is present, will you call it as a left or right, or what will you call it? The idea here is, see, for something to be a left leaf, see, the concept of left and right comes only when it is a child of a parent, right? When you have a single node that is only a root node, there is no concept of left and right, first of all. So in this particular case, it cannot even qualify for this particular question, so answer will be 0, as simple as that. Okay, I hope you understand. See, the concept of left and right comes only because we have children of a particular node, right? We have a parent node for them. If parent, see, that means there is a hierarchy, right? But if you have a single node, how can there be hierarchy? How the concept of left and right even come here? Okay, so that's why for the example 2 we do not have such a case, so answer will be 0, as simple as that. Now coming to how to code it. Before that, because I want to make this video for every class of students, for example beginners, mid, or advanced people as well. So let us first of all do a deep dive into what is this. If you're new to a lead code, definitely we'll have to understand this as well. So each node basically is object of this particular class. Okay, we call it as the tree node class. So what happens is each node basically has these particular properties. What are they? They will have a dot val, that is, they will have a value which is integer. Okay, by default it will be 0. They will have a dot left property, Okay, in this case by default it will be none, and similarly they will have a dot right property. By default it will be none. Why the concept of left and right is coming? Because it is going to be a binary tree, which I've already mentioned you. Now what is the concept of val? Val is basically the, as you can see here in this particular, the circle is basically the node, and the value 3 is basically the val value. Okay, val value, as simple as that. We are calling it as the val. So as simple as that. So whenever you create object of this particular class, you will have these properties. Okay, dot val, dot left, and dot right. So these are the some things. These are something which is given to us. Okay. Now coming to the question. So first of all, I will declare a variable called answer, which will be my answer. You can also call it as a sum or something like that. Okay, because ultimately we are getting the sum here. So yeah, now I will define a DFS function. Okay, this is my DFS function, and then I'm making a call to my DFS function here. Okay, here. Now, because the concept of left and right is involved, so I will include them in my function header. What are they? See here, I am first of all taking the root, which is again passed as the first parameter to me. Then I'm having two variables called L and R. L and R basically refers to left and right. We'll come to that, but let's see the base conditions first. What is the base condition? If the root is none, simply return it. As simple as that. Okay. Now, what are the further conditions? If this condition is not executed, that means the root is not none. If the root is not none, then definitely it will have a val, it will have a left, it will have a right. Okay. So what we'll do, we'll check that. If root is left, okay, we'll come to this condition later, because this is whole question revolves around this. Before that, let us see these two, because now traversal is happening because of these two. So what I will do now, I will call this function on the left subtree, and I will call this function on the right subtree of the current node. Okay, what I'm doing, I'm calling this function on the left subtree. Now when I'm calling this function on the left subtree, I know that this is going to be left subtree, right? So I will make ls2. Okay, this is the value L, right? I will make ls2 here, because this is going to be my left subtree. Similarly, the value r will be false, because at a time only either it can be left or either it can be right. Similarly, when I'm calling the defs function for the right subtree, okay, that's the right child, what I'm doing, I'm placing the value of r. Okay, I'm placing the value of r as true, and at the same time the value of l will be false for the right, the function call for the right, node, right child node. As simple as that. Okay. Now, how to, so first of all, what is the condition of a leaf? A leaf is something for which there is no children. Okay, that is both right and left. Pointers are pointing to none. Okay, so this is the condition for that. Root dot left is none, and the root dot right is none. Okay, so these are the two conditions for a leaf. Now we are talking about a left leaf. How do I know whether it will left leaf or not? Left basically means that it should be with the left, child of its parent. For that, what I will be checking? I will be checking the L parameter. What is the L parameter? It is something which is coming to me from the function call. Okay, if L is also true, see, these are the two conditions for being a leaf. Okay, and this is the condition, sorry, these are the two conditions for being a leaf, and this is the condition of being a left leaf. Okay, so if that is the case, what I will do, I will call the, that is, I will add the root dot val to the answer. Okay, as simple as that. After this is being done, okay, you can also return it basically, so we don't execute the code below that. Okay, so now we will do dfs of left, and we'll do dfs of right, and finally we'll come out of it. Okay, so finally I'm doing the function call with the root given to me. Okay, this is the root given to me. I'm doing a function call with that. As I've already mentioned, when we talk of the root, there is nothing called left and right, because it has no parents, so initially both of them will be false. Okay, both of them will be false, and finally I'm returning the answer. So let me quickly run this and show you. I've already segmented this, and it works. You can see it is getting accepted for both the test cases. I've already submitted this. Okay, so this question was around trees, and if you know the traversal property, basically, if you know what is a root, what is a leaf, and if you are able to figure out what is a left leaf and what are the conditions for it, I'm sure you will be able to do this question. I use the DFS approach for it. Okay, depth first search, because see, basically what I'm doing is I will go first throughout the left all left subtrees I will take first, and then I will come backtrack, and then I can go to the right, and something like that. Okay, so this is the DFS approach. You can tweak any approach for that reason, but remember one thing, only thing which you have to ensure is that you should be able to capture the left leaf. As simple as that. So Afan, that was all for today. If you like this approach, if you like my videos, if you like my efforts, please do consider subscribing to my channel. It gives a really lot of motivation. At the same time, it gives me reason to make videos further. And at the same time, see, the idea is very simple. If you code, only then you will be able to discover that you have something in you which is different from others. Okay, that is one thing. Because see, if you continuously code, then a time will come that approach which you write will be unique to you, because no one else could think of that, because this comes from the experience, right? So that's why I'm saying, like, you should be coding it, because if you want to discover something which is not existing, see, these all algorithms came because of that only, right? If no one would have tried them, then they would not have got it. Okay, everything cannot be learned from book. Okay, some things are discovered on the go. So that is what it is. If you stop coding, then definitely will become irrelevant one day. Okay, if you want to be relevant in this particular job, then definitely coding is something which you should be looking forward to. So yeah, friends, that was all for today. See you tomorrow. Thanks a lot.